Okay, today we're talking about the remainder theorem and the factor theorem. All right, remainder theorem we talked about yesterday when, what do they care about with the remainder theorem? The remainder, that's it. That's all they care about is the remainder. When we talk about the factor theorem, you're proving if something is a factor and you're going to figure out how it's a factor. So this question says, show that these two things are factors. How would we show that? Well, use synthetic division. I'm going to synthetically divide using this, and I'm going to synthetically divide here. So with red, my x minus 2, what am I going to put in the corner if we're going to synthetically divide? Positive 2, right? You set your, whatever you're dividing by equal to 0, and then write out your coefficients. So you have 2, 7, negative 4, negative 27, and negative 18. Everybody with me? So synthetically divide. Bring down your 2. 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. What's negative 4 and 22? 18. Okay. What's 18 times 2? 36. What's negative 27 and a 36? 9. What's 9 times 2? 18. Negative 18 and positive 18 is 0. Okay. Let's do the same thing with 3. What am I going to put in the corner if I'm going to use x plus 3? Negative 3. Yep. So again, 2, 7, negative 4, negative 27, and negative 18. Bring down your 2. What's 2 times negative 3? Negative 6. What's 7 and negative 6? 1. What's 1 times negative 3? Negative 3. What's negative 4 and negative 3? Negative 7. What's negative 7 times negative 3? 21. What's negative 27 and 21? Negative 6. What's negative 6 times negative 3? 18. And my remainder is 0. What do you guys notice about the remainder in both cases? It's 0. When you do synthetic division and your remainder is 0, that means something is a factor. Like you can divide that whole polynomial by x minus 2 and x plus 3. If you did long division, it would come out and be, your remainder would be 0. So it's like you say, it's divisible by that. So it's a factor. So what we're going to do is we're going to use synthetic division to find factors. We're going to factor problems that are larger than what we normally and traditionally use as far as factoring is concerned. So when the value, what I just said, when the value of the remainder is 0, that means it is in factor and it's an x-intercept. So when they ask you to find the x-intercepts, guys, remember, x-intercept is the same as zeros, solutions, roots. It's a factor. So we're going to do something called the rational zeros test. Now, in Miss Chris Weiser's class, in Honors Advanced and in Pre-Calc, they do problems that are a little more in depth. When we do this, we're going to do something called P over Q. Every time we do P over Q, your Q value is going to be 1. You'll see what I mean by that in a second. But what the rational zeros test does is you're going to list out all the possible zeros that they are, and then you're going to use synthetic division to find out exactly what they are. Meaning, P is going to be the factors of the last term. It's always going to be the constant because we're going to write it in order. What do factors mean? What times what equals something? So the factors of 6 are 1 and 6, 2 and 3, right? Your leading coefficient, that's the number that's in front of the variable with the biggest exponent. Your Q for our class is always going to be 1. Because we're not going to deal with fractional stuff like that. So for our purposes, your Q value is always going to be 1. You'll see what I mean in 1 second. So we're just going to do a whole bunch of synthetic division. So here is a question. It says find all the rational zeros. What that means is factor, right? Set your problem equal to 0 and factor. Now, what I would suggest that you guys do first is try to factor it. If you have 4 terms, how do you factor when you have 4 terms? Group, okay? So if I group the first 2 and the second 2, what can I take out of my first group? X squared. So I'm left with x plus 8. Can I take anything out of the second one? No. So God bless you. If factoring, God bless you, traditional factoring doesn't work, this is when we have to do P over Q. The way that you do P over Q, it's a little trial and error. It's going to seem a little bit like, wait, what? But you'll see, it's not that bad. You take the factors of the last number. Don't worry that it's negative, because we're always going to account for plus or minus. So you're going to say plus or minus. What are the factors of 20? 1, what? 2, 4, 5, 10, and 20, right? Now we're going to use trial and error. We're going to try to figure out which one of these is a factor. How do I know that? When I do synthetic division, your remainder is 0. And then we'll be able to fully factor from there. How many answers, how many zeros does this problem have? 3. All right, I know it's 3 because that's my highest exponent. So what you're going to do is you're going to try synthetic division. I'm going to start with positive 1 and see if I get a remainder of 0. It does not take a long time, I promise. You're not going to have to do synthetic division like 15 times. So let's write out our coefficients. 1, 8, 11, and negative 20. 8, 11, negative 20. So bring down your 1 and synthetically divide. We multiply to the corner and add down. 1 times 1 is 1. 8 plus 1 is what? 9. 9 times 1 is 9. 11 plus 9 is 20. 20 times 1 is 20. And negative 20 plus 20 is what? What'd you guys just figure out? 1 is a factor. One of your zeros is x equals 1. Now, there's 2 more zeros that I have left to find. There's 2 more zeros that I have left to find. What is my resulting polynomial here? How would I write this equation? X squared. Good. It always starts 1 less. So x squared plus 9x plus 20. And then we say equal to 0. Now, you can do synthetic division again. You can do that P over Q, list all the factors. But 90% of the time, once you find one of the zeros using synthetic division, you can factor the result. Are there factors of 20 that multiply to give me 20 but add to give me 9? What? X plus 4 and x plus 5. So my other 2 zeros are x equals what? Negative 4 and x equals negative 5. And that's it. Now, if I were you, I would list out the factors and always start with 1, and that doesn't work, go to negative 1. Then go 2, negative 2. Some of you are like, I'm going to start with 5. Okay, fine. The problem with that is if you jump around and just try random factors, don't have any sort of order, it could take you a long time. Say it again? Yeah, I just think it's easier to start with 1 and then try negative 1 and then 2 and then negative 2. And then, like, don't just start with like, oh, I'm going to try 10. Oh, that didn't work. I'm going to try negative 4. You know what I mean? Like, just kind of have some sort of a system, I think is the best way. All right, we're just going to do this a couple more times. Again, always see if you can factor. Try to group it. It doesn't group. So we're going to list out the factors of the last number. Plus or minus, always, because you're going to account for either. What are the numbers that multiply to give you 6? 1, 2, 3, and 6, okay? So again, I'm going to start with 1. As soon as I see, oh wait, that's not going to work, just stop. You don't have to do the whole synthetic division. As soon as you see I'm not going to get a remainder of 0, just stop. So bring down your 1. What's 1 times 1? 1. 2 plus 1 is 3 times 1 is negative 5 and 3 is negative 2. Is this going to give me 1? I mean, is this going to give me 0? No, so just go to the next one. 1, 2, negative 5, negative 6. Sure. 1 times negative 1? Negative 1. 2 minus 1? 1. 1 times negative 1? Negative 1. Negative 5 and negative 1? Negative 6. What's negative 6 times negative 1? 6. What's my remainder? So what did you just prove? X equals negative 1. One of my answers is x equals negative 1. Now, how many answers are we missing? There's still 2 more left. So what? Go ahead and write your resulting polynomial. How can I write that? X squared plus x minus 6 equals 0. Perfect. Can I factor that? What are the factors of negative 6 that multiply to give me negative 6 but add to give me 1? Good. Plus 3 and minus 2. So what are your other 2 zeros? X equals negative 3 and x equals positive 2. Perfect. Everybody okay? All right, we're just going to do a bunch more. Just going to do some more. Oh, here's a long one. How many answers should I have here? 4, okay? There's nothing I can do. I can't group. This isn't a trinomial, nothing like that. So I'm just going to go ahead and list out the factors of 12. So plus, minus, 1, 2, 3, 4, 6, and 12. You're never going to have to do synthetic division that many times. Start with 1. So I have 1, negative 4, negative 13, 4, and 12, right? Make sure your signs are right. Make sure you didn't skip anything. Everything on the quiz will work out. You won't get any that's no solution or anything. So if you don't find a factor, you made a mistake. So go to the corner. 1 times 1 is 1. Negative 4 and 1 is negative 3. Negative 3 and 1 is negative 3. What's negative 13 and negative 3? Negative 16. Negative 16 times 1 is negative 16. What's 4 and negative 16? Negative 12. What's negative 12 times 1? Negative 12. What's my remainder? 0. What'd you guys just prove? X equals 1. One of my factors is x equals 1. So write your resulting polynomial. Since I started out with x to the 4th, my answer is x cubed minus 3x squared minus 16x minus 12 equals what? 0. All right, you can, if you wanted to at this point, you could absolutely go ahead and do synthetic division again. But I'm going to see if this groups. Since I have 4 terms, I'm going to see if this groups. What can I take out of x cubed minus 3x squared? Okay, take out the x squared. I'm left with x minus 3. What can I take out of negative 16 and a negative 12? Negative 4, and I'm left with 4x plus 3. Oh, wait. Does this one group? No. So what do we have to do again? Synthetic division again. All right? No big deal. But that's exactly the process that you guys should do every single time. You should check, is this going to group? If it does, super. If it doesn't, we just do synthetic division again. So what are the factors of 12 again? Plus, minus 1, 2, 3, 4, 6, and 12. Should I bother doing 1 again, since we already had 1, 1? Can you have the same x value more than once? Yeah, it's called what? Multiplicity. So just because you had one factor already listed, you could have the same factor again. So I would again start with 1. So 1, negative 3, negative 16, negative 12. It may not work, but I'm just saying you could have the same factor more than once. So 1 times 1 is 1. Negative 3 and 1 is negative 2. Negative 2 times 1 is negative 2. Is this going to work? Okay, go to the next one. So I'm going to try negative 1 now. So 1, negative 3, negative 16, negative 12. 1 times negative 1 is negative 1. 3 and negative 1 is negative 4. Negative 4 and negative 1 is positive 4. Negative 16 and 4 is negative 12. Negative 12 and negative 1 is positive 12. So what did we just figure out here? X, another answer is negative 1. Perfect. So how many answers total should I have? 4. How many do I have right now? 2. All right, so let's take our resulting polynomial. What's left over here with 1, negative 4, and negative 12? X squared minus 4x minus 12 equals 0. Can we factor that? X minus 6 and x plus 2. You guys agree? So I have 2 more zeros at x equals positive 6 and at x equals negative 2. So let's talk about this for a second. All right, I have 4 answers. How many times do I have each one of them? 1 time. So what's this graph going to do at each one of those x values? Go through or bounce off the x-axis? It's going to go through. Good. You should be able to tell me the end behaviors of this graph just by looking. The highest exponent is what number? A 4, right? It's even. So is it positive or negative? Positive. So what is the end behavior of this graph? If it's positive, even. Rising left, rising right. Going up. Does that make sense? Yeah, if we were to graph this, think about it. You just told me it was rising left, rising right. So look, here's my graph. Rising left, rising right. I have an intercept at -2, -1, 1, and 6. So, and it goes through, you said, right? So I'm going to go through. And there you go. Okay, let's look at the last one. Well, the last one on this page. Can I group this? Can I factor it? Can I use the quadratic formula? No. So I have to do P over Q. What are the factors of 1? Plus minus 1, right? So if I'm going to do my synthetic division, I'm going to start with 1. What are my coefficients here, guys? 1, 0, good. 1, 1. So bring down your 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. Is this going to work? No. Okay, let's try -1. 1, 0, 1, 1. 1 times -1 is -1. 0, -1 is -1. -1 and -1 is 1. 1 plus 1 is this going to work? No. Do I have any other factors to try? No. So are there any rational zeros for this? No. Your answer would be none. You will not have one like that on the quiz. I just wanted you guys to see that because after our quiz, when we go to section 2.4 and we start talking about imaginary numbers, then it is a possibility for you guys to have none or no solution or irrationals. I mean, I'm not sorry, not irrationals, to have imaginaries. So we'll get there.